be the major elimination product of trans-1-bromo-2-methylcyclohexane in the presence of sodium hydroxide. So I drew out sodium hydroxide, and I drew out this molecule. I drew it kind of to reflect the answer choices, like I drew the CH3 on the same position that they drew it in the answer choices to make that a little bit easier to see. So I drew that out, and now I want to figure out the major elimination product. First thing we do is we look at the base for elimination. We see that this is a strong base, and it's small. Just get in the habit of that. But again, for this one, it's not so much of a big deal. But now we know that we're going to be doing E2. And E2 is a concerted mechanism. And the little trick about E2 is the alkyl halide has to be like on the complete opposite side of the molecule. It has to be antidiaxial. So I drew in the hydrogens on each side of the halogen, and now we have to decide, okay, can we do, since we have a small base, we're thinking, okay, we're going to be making the Zaitsev product. But that's actually a trap for this question. Here we actually need to see if the Zaitsev product is actually even possible. And we're going to actually see that's not possible. Remember, Zaitsev is the more highly substituted double bond product. And remember, small goes with Zaitsev, huge goes with Hofmann. Just as a side note. So now we're not worried about the hydrogens on this side because there's two to choose from, and so one of them is going to be antidiaxial from the bromine. So I drew out the chair conformation to look at this hydrogen and bromine, and as we can see, they're not antidiaxial. So here, with this chair conformation that I drew, bromine is on the down equatorial. A lot of people might just be able to see this, but just as an explanation, I drew out the chair conformation. So we can't do E2 from this side, so the Zaitsev product isn't possible. We have to form the Hofmann. So when we have our strong nucleophile, the way the mechanism works is the strong nucleophile grabs the hydrogen that's axial to it, and the bond between hydrogen and carbon forms a double bond, and then the bromine leaves. And so the final product that we get from this, our major elimination product, is actually answer choice A. So this was answer choice A. So you really need to be careful. Look and find where your hydrogens are. If you can't see it, just draw the chair, but be very careful because it's easy to mess up chairs. So yeah, but a pretty straightforward problem overall. So.